Okay, I'm going to go ahead and finish up our notes. Last class we did talk about the sum and difference identities. Today we were supposed to talk about the double and half angle identities. We did run out of time in class, so I did promise you a video going over the last examples. So if you have not done so already, go ahead and pause the video, copy down the double angle identities that we will be using, and then also add in the half angle identities. I'll go through these through a homework problem with you. Okay, so here we go. We're looking at example 4. Solve this equation in the interval from 0 to 2 pi. We're going to use the double angle identity for sine of 2x, and we're going to say that this is equal to 2 sine x cosine x. So I'm going to rewrite this problem. I have 2 cosine x plus 2 sine x cosine x equals 0. So now when I look at this, I see that they both have a 2 cosine x in both terms, so I can factor that out. So this one has a 2 here, this one has a 2 here, this one has a cosine x, and this one has a cosine x. So we're going to factor that out, 2 cosine x, and write down what's left over. So here I factored out basically everything, so that's going to leave me with a 1 there. Okay, here I factored out the 2 and I factored out the cosine x, but I'm still left with sine x. So that gives me 2 different pieces that I can set equal to 0 and solve for x. So we have 2 cosine x equals 0, and we also have 1 plus sine x equals 0. So here if I divide both sides by 2, I have cosine x equals just 0, because 0 divided by 2 is still just going to be 0. Here we're going to subtract the 1 to the other side. So we have sine x equals -1. We want to go back to our unit circle, of course. And so we're saying where on our unit circle is cosine equal to 0? Remember that cosine is your x coordinate. Okay, so we're looking for x coordinate to be 0, not happening yet. Okay, so it's happening here at pi over 2, and then it's happening again down here at the bottom at 3 pi over 2. So this one gives us that x is equal to pi over 2 and 3 pi over 2. Okay, then we go to when does sine of x equal -1? So on the unit circle, we're looking for, remember sine is the y coordinate, so we're looking for where is y -1? So nope, not happening, nope, not happening, no, not happening. So it's happening down here at 3 pi over 2. We already really found that solution when cosine was equal to 0. So our final answer would just be that x is equal to pi over 2 and also 3 pi over 2. We don't need to write the 3 pi over 2 twice, okay? We already covered that. So now let's take a look at example 5. Kind of started this one for you in class today, but that's okay. We'll go ahead and look at it anyway, as if we've never seen it. So I have to figure out how to draw my picture, okay? Which quadrant am I in? So notice that cosine is negative, and we know that tangent is also negative. Okay, so we go back to thinking about our all students take calculus. All students take calculus. So this quadrant 1, is where all the trig functions are positive. This is where only sine and cosecant are positive. This is where tangent and cotangent are positive. And then this is where cosine and secant are positive. So we need cosine to be negative, so that cannot be in this quadrant. That's where everything's positive. And that cannot be in this quadrant because that's where cosine is positive. We need tangent to also be negative, so it cannot be that one because that's where tangent is positive. It can't be in that third quadrant. So that means our triangle is going to have to be drawn in the second quadrant here. Okay, so we have our angle. Let's see. So cosine is adjacent over hypotenuse because of our SOHCAHTOA stuff. Okay, so we cannot have the hypotenuse be negative, so that negative is going to have to attach to the 40. So our 41 is going to be our hypotenuse. The adjacent side is going to be -40. And based on which quadrant it's in, that makes sense if you look at it, because the x direction is negative over there in quadrant 2. We need to solve for the missing side here, so we are going to do our Pythagorean theorem. We have a squared plus b squared equals c squared. So I'm gonna let A be my unknown. So I have A squared plus negative 40 squared equals 41 squared, okay? So I have A squared plus 1600 equals 1,681. Subtract the 1600 from both sides, we get A squared equals 81, so A must be 9, because you want to take the square root of both sides, so A must be 9. So our missing side over here is a positive 9. In order to solve your double angle formulas, for sine, we're going to need, for sine of 2 theta, we're going to need both sine and cosine. And then for tangent of 2 theta, we're going to need tangent. So I might as well go ahead and set up all of my trig functions, sine, cosine, and tangent. So sine of the angle theta is going to be equal to opposite over hypotenuse. So that's going to be 9 over 41. Cosine of theta is adjacent over hypotenuse. So that's going to be negative 40 over 41. Yes, I realize we were given that, but I just want to verify it. And then we have tangent of theta is opposite over adjacent. So that's going to be 9 over negative 40. Okay, we're going to plug that in once we need those pieces. So sine of 2 theta, if you look at your notes, sine of 2 theta is going to be 2 times sine theta times cosine theta. So this is equal to 2 sine theta times cosine theta. So I have 2, nothing happens with that. Sine theta, we just found out was 9 over 41. So we're going to replace this whole thing with 9 over 41. And then cosine theta, we just found out was negative 40 over 41. So replacing that whole thing with negative 40 over 41. Using our calculator, we're going to let it handle it for us. We're going to do 2, let me clear out what's there. We're going to do 2 parenthesis alpha y equals, will give you that fraction button, love that. So we have 9 over 41. Get off the fraction, close up your parentheses, start a new one. Alpha y equals, to get our fraction button, we're going to do the negative sign and then 40 over 41. Okay, close out the parenthesis, and so that gives us that great big answer of negative 7. It's actually a really small answer, but big numbers. Negative 720 over 1,681 would be our final answer here. Please, 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 on your quizzes and tests, box the final answer for me. So that I'm not hunting through figuring out where did you stop, what answer do you want me to grade, okay? So next we're going to do tangent of 2 theta. So we're going to be using this formula here, 2 tangent x over 1 minus tangent squared x. But actually we're going to be using theta. So we're going to say this is equal to, let's see, lost it here, 2 tangent theta over 1 minus tangent squared theta, okay? This little square here sometimes, scares students. Don't be scared of the square that's in there. You're still just going to plug in what tangent is, and then whatever we get, we're just going to square that. So don't let the square, worry you, make you anxious. Just go ahead and square whatever tangent theta is. So we have 2 times what's tangent theta. That one's going to be the negative 9 over 40. And then 1 minus, again, tangent theta is just negative 9 over 40. And then whatever we have, we need to square that because of the square here. And you can use your calculator on all of this. Okay, so I'm going to go through the steps. We have, trying to show the problem and show the calculator, sorry about that. I'm going to do alpha y equals to get that initial fraction button. Then I have 2 times parenthesis. I need another fraction, and yes, your calculator can handle fractions within fractions. It does a great job with that. On the bottom, we have 1 minus a fraction. So let's do our fraction button again. Alpha y equals negative 9 over 40. Don't forget to square it and press enter. And that would be our answer. We have negative 720 divided by 1,519. Okay, so I plan to do a couple of the homework problems, but I'm going to put those up in a separate video. So if you want to see the half angle problems worked out, again, go ahead and watch the second video that I'm going to post. But this should finish out our notes for us from today.